Okay. Okay. Good morning to one and all. Today, I would like to explain about the concept of the introduction to embedded systems. Okay. So before going to this lecture, mm, first of all, what is an embedded system? So an embedded system is a system which is a combination of both hardware and software, which is used to perform a specific task. A specific task. Or in general, we can say embedded system is an electronic or electromechanical system which is designed to perform a specific function, and it is a combination of both hardware and firmware. Firmware can be also called as software. Now, what is the purpose of an embedded system? So the purpose of an embedded system is we are going to design a system which is going to perform a specific task. Okay. So the best example of an embedded system is electronic toys, mobile handsets, washing machines, air conditioners, automotive control units. It can be anything. It can be anything which is going to perform a specific task, and that system should contain both hardware and software. So the embedded systems are unique in character and behavior. So that means the purpose is to design the system for a specific task. Okay. And one more point is with specialized hardware and software. So customized hardware and software. So the purpose is to uh, work the system for only for a particular application, for a particular application. Now let us say one example. Okay. So there is a fan in your home. Okay. There is a fan in your home. So the fan is an electrical device. Okay. It's a normal electrical device. Suppose if I control the fan with a microcontroller, it's an embedded system. It's an embedded system. So that means I'm adding some intelligence. I'm adding some intelligence to the system. So if you are adding some intelligence to a normal system, then it becomes an embedded system. Okay. Next, we are going to differentiate the embedded system versus the general computing system. So the embedded system is a system which is a combination of special purpose hardware and embedded OS for executing a set of applications. But if it for a general purpose system, it is a system which is a combination of generic hardware and general purpose operating system for executing a variety of applications. So it's a general purpose and it is a special purpose. So it contains a general purpose operating system. So that means for every system, we require an operating system, okay, which acts as an interface between the user and the system. So the general purpose system contains the general purpose operating system. So the embedded system, it may or may not contain an operating system for functioning. And the applications are alterable by the user in the case of general purpose system. But whereas in the case of embedded system, the firmware of the embedded system is pre-programmed and it is non-alterable by the end user. Okay, now I'm going to let us take one example. I'm going to monitor the temperature of a room. So for that, I need to write one code. I need to write one code, and that code is called the firmware. That firmware is pre-programmed. So that means that should be downloaded into the memory. So based on that program, the system will work. So you cannot modify that program. You cannot modify that program. And the performance is the key deciding factor on the selection of the system in the case of general purpose system. So this is called application specific requirements like performance, power requirements, memory usage are the key deciding factors. Okay. Now less are not all tailored towards reducing the operating system power requirements, options for different levels of power management. So whereas in the case of embedded, it is highly tailored to take the advantage of the power saving modes. So that means there are various power saving modes which can be supported by the embedded system. So the response requirements are not time critical. So there is no time bound line in the case of general purpose system. But whereas in the case of embedded system, for certain category of systems like mission, like military applications, the response time requirement is highly critical. Here it need not be deterministic in execution behavior. So that means there is no need to, there is not a predefined time for the execution behavior. But here the execution behavior is deterministic. So that means which can be determined for a certain type of embedded systems like hard real-time systems. So we will discuss the hard real-time systems later. Okay, so this is about the introduction of the embedded system and uh, the difference between the general purpose operating system and an embedded system. Okay. Now, the history of an embedded system. Okay. So the first recognized most modern embedded system was Apollo Guidance Computer, which is AGC. The first mass-produced embedded system was Atonix D17 Guidance Computer. Okay, so this is about the history. Now we are going to classification of embedded systems. Okay, so we can classify the embedded systems based on 4 different categories. The first one is based on generation. Second one is based on complexity and performance requirements. Third one based on deterministic behavior, and fourth one based on triggering. Okay, now we are going to discuss about the classification of embedded systems in the next video. So thank you for listening this video. Okay.